It's my privilege to talk to you a little bit about what we do at EPFL and also in view of possibilities of collaborating even more than we do now. So just to give you a glimpse of what we are, we have heard about the system in Switzerland yesterday from Joël Mézot. EPFL is part of the same system as ETH Zurich. We are the two federal schools of technology. We have about 14,000 students, of which 3,000 are roughly graduate students, almost 400 professors, so 400 research groups. And we are judged in some years, I'm not sure exactly how it works, as the most international university in the world. Don't ask me the algorithm, but it means we are very international. We have 130 nationalities and many foreign faculties and many foreign students, of course. So we cover a wide range of spectrum of activities from the fundamental sciences, math, chemistry, physics, which are, of course, the core of our activity, but as is engineering in all of its declination, if you like. We also have a School of Life Sciences, so quantitative biology, I should call it, with also a good spectrum from fundamentals to clinical applications, management of technology, humanities, to help our students have also really a vision that goes beyond just technology. And of course, we have a School of Computer and Communication Sciences. And we have the School of Architecture, which is like a more artistic side, coupled with the civil engineering and environmental engineering, which are a little bit more quantitative, I should say. The three areas that we judge of high priority for us, leading to a number of strategic initiatives, are not a surprise today here: sustainability and energy transition, healthcare innovation. We have a lot of health tech developments, including in the private sector as spin-offs and so on, and AI. Now, sustainability means quite some extent energy as well. The gas emissions by sectors indicated in the left underline the fact that energy is in industry and in buildings and in transport is one of the main causes, of course. And also we understand, we know how the economics of energy is complicated, even within Europe, that sometimes we refer to as one single entity. In fact, we have a lot of differences depending on the energy mix of each country. These are the costs of the electricity for normalizing to the so-called power purchasing power standard per country, and you can see different colors, meaning that even across small and local borders, you have quite a variation, and that's make it complicated. And of course, we also work not just for ourselves, not just for Japan, but also to help the whole world to develop together with us, as we visualize here, showing that the share of population with access to electricity is really not fairly distributed. Now, we have, of course, the role of educating people, and that's also something I would like to underline. People need to be educated in the sustainability, in the energy sector. We want people who can discuss in a quantitative way and an informed way what the potential possibilities are and what the solutions can be. We form what we call a polytechnical education, so with fundamentals of math, physics, and computational thinking, of course, using and teaching AI, of course, with an ethical approach that permeates all of this, because you have to do it for the good of mankind and of society, working in teams. But all of this has to be done in a sustainable way and preparing students to be citizens who will actually work for sustainability. So they have classes on sustainability. Every class on different topics has to have a sustainability element embedded in it. We have students working hands-on, and this is important also for academic friends in Japan. I'm here in Japan not only for this event, but also to visit a number of universities and establish even further collaborations. And I look forward to having exchanges of students. Students come to us, and they can work hand-on on the fastest solar powered boat. We are about to hopefully to beat the world record of speed on water with a solar powered both. We have but been participating to the Formula One for solar cars, and also to this Hyperloop project, which is a transportation system. Of course, I don't need to tell you how important in Japan to go fast from one place to the other. We need to make vacuum to go fast. You don't need that, but this is a project that's interesting for many countries in the world. We have launched, this is a demonstration how our community is prone to mission-oriented research. We have launched a project which we call Solutions for Sustainability, in which we sponsor centrally from our, let's say, central financial resource, demonstrators for sustainable solutions on campus or on campuses. We have more than one campus, both long-term and short-term. So that means the projects have to be developed to reduce our emission. The projects have to be developed to optimize the use of energy and to produce new ways, for example, for sterilizing systems, etc. And they have to do it on campus, not just theoretically, not elsewhere, but they have to be applied on campus. And this is a great success. Some of them are longer term and large scale, including a project on carbon capture, utilization, and storage, and including a project that uses the heat produced by data centers to actually make electricity and to be integrated in a local grid. So that is one way to do it, let's say, from academic center, but also, and that's another thing that I think we should discuss with Japanese friends, and I've been discussing in different universities in the last few days, how to transform that to innovation, how to actually make that happen across the border between academia and industry. And we have a lot of startups at EPFL. We have a lot of startups that are active in the area of sustainability and energy as well. So 9 out of the 24 that were judged in the top 100 in Switzerland are related to sustainability. We have, as Yasmin said in the introduction, a very wide spectrum of activities at EPFL. She said we're number one in the world. I don't know how you know that, but we're good. We're good. Okay. So we have 100 labs and research groups that work on energy in many areas. So we are very happy to collaborate with the groups here. I mentioned a few initiatives. One is in valleys is the area we have heard about that yesterday. Of course, is the area with high peaks, high mountains in Switzerland. That means also a lot of hydro, highest concentration of hydro, I believe, in the world per square kilometer. And that's where we develop not only hydro, but actually the green energy portfolio. Again, EPFL, but not only academic, also in conjunction with local institutions and industry. We have this initiative across Switzerland to embark also, again, private partners to go along the question of carbon. And we are now a little less shy. As you know, in Europe, we had to be shy on nuclear for many years. And in Switzerland, we can be now less shy that we have quite strong research on nuclear fission and security, and a strong research, of course, embedded in international framework in fusion, which is my own personal field. So I cannot not show a little movie about that. As you know, I hope it works. It worked yesterday, and then I don't know why. Yeah, it's coming. So this is our own fusion machine in EPFL, which is one of the most important fusion machines in Europe. It's small compared to the world fusion machine, and it's small compared to the largest operating tokamak, which is in QST in Japan, in Naka, with which, of course, we collaborate. But nevertheless, it tests and develops crucial elements to understand how to trap this little star on Earth and get out of it clean energy. So now we're going inside. This visualization was done by the same group of EPFL. They made visualization for a number of things in different events in the world, including the Osaka Expo. So we are visualizing now what's happening in reality 20 to 30 times a day inside our machine. This is the exact design of our machine. These are the traces of our particles of the little star that's trapped there. And then it's brought to the temperature that's much higher than the temperature of the core of the sun. And that's the condition which we need to have fusion. We work in this center For ITER, which, as you know, is an international treaty in which, of course, Japan is present and is very active. And ITER will demonstrate the scientific feasibility and technological feasibility of fusion and its safety. But it's not yet the step that will demonstrate that we can actually produce electricity and sell electricity from fusion. This step we refer to in Europe as demo, and we are already preparing that together with all of our European consortium, which I personally had the pleasure to lead until a few months ago, but also together, as I mentioned before, with the very strong Japanese teams, which are also part of a collaboration between Europe and Japan. And that's a picture of the GT60SA, so-called device in Naka, which is, as I said, the largest operating tokamak, this kind of machine, this kind of trap for a star on Earth in the world. So that's something that we are very happy to do. And I mentioned here a few collaborations that we have with Japan, not to show how many they are, but to show how few they are, because in my opinion, we can have much more. We can have much more, and we can have much more, not only academic collaborations, but exchanges between companies and exchanges between best practices to involve companies in the area of energy and sustainability in general. And I think I have seen already in the last two to 3 days many opportunities for doing so in many areas. And then this event is also something that is great to facilitate that. So we can collaborate because we know how to collaborate already, but we can do much more. And by the way, we have now been back in Europe in the system for research in Europe, which has the largest program in the world, and it's going to be double even that size in the next framework program in Europe, which is 7 years. And I know Japan is also being considered for an associate member together with us. And I know it's 0000 now. Thank you for your attention.